Today's lesson will be on solving problems involving right triangles. That matches up to 6.5. So before we get into today's lesson, we are assuming that you are good with the tan, the cosine, and the sine ratios for solving for missing angles and side lengths. So if you're still a little iffy on solving for missing angles using the inverse functions or missing side lengths by flipping that unknown into the numerator, solving for missing side lengths, go back, complete your exercises on Khan Academy or your textbook homework and make sure you are comfortable with those things because we will be using those over and over in today's and the following lesson. So today's lesson, we are going to draw a diagram from a word problem involving a right triangle. So very important, we're only using right triangles right now, and right angle triangle, and solve for the missing side lengths and the angles. So it's essentially the same thing we were doing before. We're just going to step it up a notch, put this all into a word problem, and make you draw a diagram and solve for the missing pieces. So most students usually find just drawing the diagram is usually the hardest part. Once you get the right angle triangle with the sides and the angles labeled appropriately, the questions usually flow quite nicely. So example 1, a boy flies a kite at 100 meters above the ground. The angle the kite string makes with the ground is 55 degrees. How long is the kite string to 1 decimal place? So a nice diagram has been drawn here for you. And we can see we are solving for this missing x on this side with an angle down here in the bottom left corner. A lot of these problems will involve the ground for the next couple problems unless it otherwise says so. The ground is always flat. We're working in a perfect mathematical world where the ground is flat and buildings hit the ground at exactly 90 degrees. So let's get started. First thing we have to take a look at is labeling our triangle. So if the angle we're looking at is 55 degrees, we know that opposite 55 degrees, we're going to call our opposite. Of course, across from the 90 degrees will be our height, and our last remaining one will be adjacent. It doesn't even look like we're using adjacent here. We don't really care about the adjacent down below. We're using op equals 100 and height equals to x, and theta is equal to 55 degrees. So that is enough information to solve because we're given 2 of the 3 pieces of the puzzle. So next we have to think what trig ratio uses the opposite and the hypotenuse, and that would be SO in SOHCAHTOA. Remember your acronym SOHCAHTOA. So I'm going to say that sine of theta is equal to opposite, which is 100, divided by my hypotenuse, which is x. I guess I can fill out all my values here. I could have replaced theta with 55. And then we can go ahead and solve this. As we see, the unknown is on the denominator. So I'm going to multiply x by both sides. X times sine 55 is equal to 100. Actually, I'm just going to write that at the same level, 100. If you didn't see what I did there, you can go back to a previous lesson. I'll show once, but I'm going to fly through this one pretty quick. I'm going to multiply both the bottom or the left side and the right side by x. So x and x divide to 1, so that's how we isolate. Now we have x on the other side. So now I want to isolate for x here once it's out of the denominator. So I'm going to divide both sides by sine 55. So x is going to be equal to 100 divided by sine 55. Once again, I just divided sine 55 into both sides. So we get x is equal to, throw it in your calculator. Make sure your calculator is in degrees. 100 divided by sine of 55, and answer shows up over here, 122.07. We can take a look at what they wanted us to round this to. It was 1 decimal place. So if I take a look at my answer, 122.07, I can round that 0 up to a 1 because the next digit is a 7 is above 5. So I'm going to say it's approximately 122.1. And we're talking meters in this case, meters. And you can put a little therefore statement and square your box around your final answer. So same type of question from before. We've got 2 of the 3 missing puzzle pieces in a right angle triangle, and we're solving for 1 of the 3rd missing puzzle pieces. Whether that be a side length or an angle, we know how to do both. Question 2. The side adjacent to the 74-degree angle in a right triangle is 6 centimeters long. How long is the hypotenuse to the nearest tenth of a centimeter, or one placeholder after the decimal? So quite often students struggle drawing the diagram. Once a diagram is drawn, it's not too challenging of a question. So first thing we're looking at is just a right angle. So I'm just going to draw a typical right angle triangle. For some reason I like to put my right angle at the bottom right hand side. Doesn't matter which direction you draw that right triangle, as long as it's got 90 degrees in there. So next thing is here we have the side adjacent to the 74-degree angle. So I know there's a 74-degree angle in here. I know it doesn't really look like 74 degrees, but this is not to scale clearly. I'm going to put that as 74 degrees. So then they're saying the side adjacent to the 74 degrees. Well, if I go ahead and label my diagram here, I know that opposite here must be my opposite side, and across from my 90 degrees must be my height. So that must mean this is the adjacent side down here. So the side adjacent to the 74-degree angle in a right angle triangle is 6 centimeters long. So they must be saying that the adjacent is 6 centimeters long. How long is the hypotenuse to the nearest tenth of a centimeter? So what they're looking for is x up here. They're really looking for what my hypotenuse is in this triangle. In this particular case, we don't even care about my opposite. We're not going to use it. I have information regarding my adjacent, my hypotenuse, and my theta. So we're going to use those 3 bits of information. My height is equal to x. My adjacent is equal to 6. My theta is equal to 74 degrees. That's 2 of the 3 pieces of the puzzle we need to solve. We just have to think what trig ratio uses height and adjacent. So ka toa, so I'm going to use ka because it uses adjacent and hypotenuse. So cosine of theta is equal to adjacent divided by hypotenuse. Fill in the values we know and solve for the ones we don't know. Cosine theta is 74 degrees is equal to adjacent 6 divided by height, which is x. Once again, our denominator is our unknown, so we want to solve for that unknown in the denominator. You can either flip both of these fractions. Technically, that cosine 74 is over 1. Or we can multiply our x by both sides, so we get x times cos 74 is equal to 6. So I multiplied both sides by x. X divided by x is 1. Then I want to isolate for x. So I'm going to say x is equal to divide both sides by cosine 74 is equal to 6 divided by cos of 74 degrees. And throw that into our calculator. 6 divided by cos 74. 6 divided by cos of 74. And we get an answer of 21.767. And let's see how many decimal places they wanted us to round. Nearest tenth, so 1 decimal place. So x is going to be equal to 21.76. That 6 is above a 5, so we round the previous decimal up to 8, 21.8 degree, or wait, 8, what measurements are we using here? Centimeter. Put a box around it, put a therefore statement, and you are good to go. Therefore, the hypotenuse must be 21.8 centimeters long to the nearest tenth of a centimeter. So once that initial drawing is set up, it's just solving one of the missing pieces in a right angle triangle and picking the appropriate sine, cos, or tan to use given the required information. Next one, example 3. So triangle ABC is an isosceles triangle with two side lengths equal to 10 centimeters and the two angles equal to 40 degrees. We know in an isosceles triangle, the base, so the bottom of the two equal side lengths have to be equal degree measurements, those angles. Determine the height of the triangle, determine the perimeter and the area of the triangle. So first thing I'm going to do is draw my picture perfect isosceles triangle. Looks something like that. Those look about 10 centimeters. Those look a little more than 40 degrees. But we're saying this is equal to this. So A, B, C, where this is 10, this is 10. If those two sides are equal in length, we know that the angles at the base of an isosceles triangle are also equal. So that would have to be 40 degrees. That would have to be 40 degrees. So there's an isosceles triangle with side lengths 10 and bases equal to 40. Then we're looking for the height of the triangle. We know the height of the triangle actually comes and hits the base at a perfect 90 degrees. And that's the trick here, because right now we couldn't solve for anything missing by using Pythagorean theorem or SOHCAHTOA because we don't have a 90-degree angle. If you ever run into this problem where your triangle doesn't have a 90-degree angle for right now, you know you probably made a slight mistake somewhere. But if I draw a perfect 90 degree, a perfect height, so that comes down and meets at 90 degree, I'm going to put one on both sides, you'll see why. Obviously my triangle is not to scale, but it's not too bad. As soon as I have a 90-degree triangle, then we can solve this problem a little easier. So I called that point where it hits point D for no particular reason. I might need to refer to that later. But you can see now I have two triangles joined back to back. So triangle ADC is a 90-degree angle, or right angle triangle, and triangle ADB is a 90-degree right angle triangle. That's going to make this a little easier to solve. And they're saying, what is the height of this red line? So what is x, that distance going up there? So we've got a couple different ways to solve for this one, solving for the height of a triangle. I'm going to look at triangle, let's go ABD, so the triangle on the right-hand side. So if I'm looking at triangle ABD, I'm going to say that my theta is 40 degrees. We're going to look at that angle. So if we're looking at this angle, then opposite that angle, opposite is going to be equal to our x. That's what we're looking for. And then across from 90 degrees, so if I look at just triangle ABD, 90 degrees is at D, so the hypotenuse must be equal to 10 centimeters in this case. And so we have two of the three pieces of the puzzle. We've got two side lengths and one angle, and we're missing that x, so we can pick and choose what trig ratio to solve for this. What trig ratio uses O and H? So I'm going to use sine theta is equal to op over hype. So we've got sine of 40 degrees is equal to x over 10 centimeters. I want to isolate for x, so I'm going to multiply both sides by 10. So we're going to get 10 times sine 40 is equal to x, because 10 divided by 10 is 1. And then I've got to throw that in my calculator, 10 times sine 40. Once again, make sure your calculator is in degrees. It needs to say degrees there. And I'm going to say 10 times sine of 40 degrees is equal to 6.427. So I'm going to round that to 6.43. Let's see how many decimal places they want in the question. It doesn't say where to round it to, so we're going to safely assume that 2 decimal places will be sufficient. 6.43 is equal to x, so that would be the height of the triangle. Question A. So then let's take a look at question B. Determine the perimeter of this triangle. Perimeter. So if we want to take a look at question B, we want to solve for that distance along the bottom. So I want to know how long is this side, because I know perimeter is just going to be 10 plus length BC. I can't use Pythagorean theorem on the original triangle, on triangle ABC, because it is not a right angle triangle. I could use Pythagorean theorem using my last obtained measurement of x. So if I knew the height was exactly 6.43, then we could use Pythagorean theorem using 10, 6.43, and my unknown side for one of these smaller triangles. So first I'm going to look for just this distance here. I'm going to choose not to use Pythagorean theorem just because that 6.43 is a rounded value. So if I can avoid using 6.43 in another measurement, it's just going to make my answer a little more accurate, because that 6.43 is pretty heavily rounded. So if we can avoid using it, go ahead and avoid using it. If you have to use it, it's the only option, then obviously we can use it. So I'm going to avoid using 6.43, so I'm not going to use Pythagorean theorem, and I'm going to take a look at how can I solve for BD in this triangle without using Pythagorean theorem. Well, I'm looking at theta being 40 degrees, so my opposite would be x. So this side would be called my adjacent down here. So really what I'm going to be looking for is this adjacent, this BD is my unknown. My theta is going to be 40 degrees, and my hypotenuse is going to be 10. So this new triangle, I'm going to have to charge my pencil. This new triangle, if we want to draw it off to the side here, if it makes a little more sense, is a right angle triangle called ABD, where we have our hypotenuse is 10. My height is 6.43. I'm going to avoid using that. This is 40 degrees. And I'm saying solve for this, the adjacent down here. So I need a trig ratio that uses height, that uses adjacent, and that uses theta. They all use theta, 40 degrees. So we can say that, so we can use the cosine ratio, because the cosine uses cosine of theta of 40 degrees is equal to adjacent x over 10. So if I'm solving for just x here, I want to isolate it. I'm going to times both sides by 10. So 10 times cosine 40, I don't really need that degrees in there, is equal to x. So I can go over to my calculator, 10 times cos 40. I just want to change that sign to a cos, a little shortcut here. 10 times cos 40 is 7.66. So if the question doesn't say, we can round to 2 decimal places. That'll be all right for now. 7.66. So I know that that base from B to D is 7.66. If just that one base is 7.66, then clearly I know from B to C is going to be twice that amount. So if I just found this is 7.66, then I know that from B to C is going to be twice that amount, because clearly those are the exact same triangles stuck beside each other. Those are similar triangles, the exact same congruent triangles. So I know that from B to C is going to equal 2 times 7.66, which is going to be 15.32 centimeters, will be that whole side. So then the total perimeter is going to equal side AB plus BC plus CA. So that's going to be 10 plus 10 plus 15.32. And I get the total answer of perimeter equal to 35.32 centimeters. Perimeter, relatively straightforward, just adding up the 3 outside sides, and we found that third side by finding just BD and then doubling it to get that full side of BC. Relatively straightforward. Once again, questions on that, come to office hours or ask your teacher. And C, solving for our area of that triangle. Area of a triangle, area is equal 1/2 base times height. We've already solved for the base. We've already solved for the height. So that full base would be length BC, what we just found in the last question. That full height would be AD, which we found in part A. So we're just multiplying those two measurements by each other. So base area is equal to 1/2 times the base, which is 15.32, times the height, which was 6.43, to get the total measurement of 49.25. In this case, area is measured in centimeters squared. So just under 50 centimeters squared would be the area of that triangle. Part C. Questions on that? Feel free to ask away. So example 4, finally getting into some bigger problems here, slightly more challenging. Once again, drawing that diagram is often the most challenging part. Once you've got that diagram drawn with your right angles in there, the question is usually pretty straightforward. So if you want to pause the video, go ahead, try this problem out, and then just fast forward to the answer and make sure you've got the same answer as me. So the area of a right angle triangle is 64 centimeters meters squared. One angle is 26 and a bit. What are the dimensions of the base and the height? So key thing they said here is the right angle triangle. Question is a lot easier once we have a right angle right in the triangle, because we can go ahead and use any one of our SOHCAHTOA, our trig ratios. So if we draw our typical right angle triangle here, I don't know why I prefer to put my right angle in the bottom right hand corner. If you put it somewhere else, that's just fine. And they're saying one angle is 26.5651, quite the measurement there. So I'm going to arbitrarily label this one 26.5651. Of course, you could label the other one 26.5651. Your height now may be your base, and your base may now be your height, but you'll get the exact same answers. And so they're looking for the height and the base. Let's label those two. So first thing we know right from the question, let's say that the area is 64 meters squared. So I know that area is equal to base times 1/2 times base times height. And we also know that area is 64. So I know that 64 has to equal 1/2 times the base times the height. I'm going to simplify this ever so slightly, bring that 1/2 to the other side. So I'm going to multiply both these sides by 2 to get rid of that 1/2. So if I multiply this side by 2, yeah, I have to multiply this side by 2. It's a time symbol. So that's the same as saying 128 equals base times height. And while that step isn't absolutely necessary, it just kind of simplifies numbers on one side and variables on our other side. Okay, so I know area equals base times height divided by 2. So I get 128 equals base times height. Notice how I have two unknowns here. I can't solve an equation with two unknowns unless I have two equations. Remember old substitution elimination. So I'm going to try to take a look at how can I get another equation. Well, looking at this triangle, if I see across from the angle we're looking at is our height. That is also known as our op. And beside our angle we're looking at is also our, sorry, not our height, is our adjacent. Height must be up here, across from 90 degrees. So we can set up another equation. Which equation uses our opposite and our adjacent? Opposite and adjacent would be TOA, tan. So TOA. So tan theta is equal to opposite over adjacent. And fill in some values. We know tan of 20, what was that number, 26.5651 is equal to my opposite. I don't know what it is. I'm just going to leave it as height, as h. My adjacent, I don't know what it is. I'm just going to leave it as base. So I'm going to rearrange this equation and solve for, or isolate for h, just get it by itself. So I'm going to multiply both sides by b, just because it was nice and easy to isolate for. So b times tan of 26.5651 must be equal to h. Following me there? So notice I've got here a equation that has two unknowns. I've got an h, but I know what h is. I'm going to put some big brackets around here so you can see that. So I'm going to choose to call this equation 1. I'm going to choose to call this equation 2. And I'm going to write out a new title called sub 1 into 2. So anywhere I see an h, I'm going to replace it with b times tan 26.5651. And that's kind of tricky part to this one. So anywhere I see an h, I'm going to replace it with that. So I'm going to start in orange. 128 is equal to b times, and now I'm not going to multiply by h because I know that h is actually equal to b times tan of 26.5651. So I've just simply replaced h with what it's equal to in the other equation. Relatively straightforward there. Then we've got to do a bit of math. B times tan 26.5651 is just equal to 128 is equal to b times b is just b squared times tan 26.5651. I'm getting a little tired of writing out all those decimal places. So if I want to solve for b, I'm going to divide both sides by that tan number. So I'm going to divide this side by tan 26.5651. Notice I haven't written out what that is because it's a big, long, ugly decimal, and I don't want to write out even more decimals. If I divide that side by tan of 26.5651, I have to divide the other side by the same thing. I'm just showing my steps here. Of course, this is quite a bit of work. You may not show those two steps. Those two would divide to 1, and I'll be left with 128 divided by tan of 26.5651. And if I want to solve for just b, oh, sorry, that should be b squared. Can't lose that squared. If I want to solve for just b, I'm going to have to take the square root of all that. So the square root of 128 divided by tan 26.5651. That is what we're going to have to type into your calculator. So hopefully I can remember that as I switch over to my calculator. the square root of, I've forgotten already, 128 divided by 26, 5651. 128, oh, that came out of my square root there. Square root of, let's put this all in brackets, 128 divided by tan of 25.5651. Oh, 1. And brackets. And that should do the trick there. And we get the answer of 16.351357. B is equal to 16.356. I guess I'm going to round to 16.36. Sorry, flipping back and forth here lots. And I just want to double check that on the calculator. So if I do 128, just going to see how this calculator works. 128 divided by tan of 26. Did I do 25? Is that why my answer is a little funky there? 5651 is equal to 255.9994. And then let's say I take the square root of that. So put that all in brackets. And take the square root of, that didn't work. Square root of 128 divided by tan of 26.5651. And delete that. Sorry about this. And I get the answer of 15.9999998. I think I must have made a mistake. I think I typed in tan of 25 instead of tan of 26. So I'm going to change my answer to 15.99999, or the answer of 16. Rounded, of course, to 2 decimal places to give us a slightly rounded answer, but that'll be okay for now. So we got my base is equaling to 16 in this triangle. Once we have our base is equal to 16, a couple different ways we could solve this. You can sub it back into one of the original equations. You could use Pythagorean. Well, we don't have quite enough to use Pythagorean theorem, or we could use one of our trig ratios. I'm just going to sub this back into, let's say, my area equation. So I'm going to sub this back into 2. So off to the side, I'm going to say sub b equals to 16 into equation 2. And that was 128 is equal to base times height. So 128 is equal to base is 16 times height, or 128 div 16 is going to have to equal to my height. Looks like we could reduce that. Oh, it goes in evenly, doesn't it? 8 times 16 is going to be equal to 128. So I've got my height of 8 and my base of 16. 16 times 8 is our total area of 128. I guess we could write out a therefore statement off to the side, saying therefore the base must be 16 and the height must be 8. Once again, questions there, just ask away via email or office hours. Okay, next problem here. We are going to solve for a very typical grade 10 introductory trig problem, and it's the old ladder leaning against the wall problem. A couple things you have to know here is the ground is always flat unless otherwise stated. So all these problems, the ground is perfectly flat ground, and that buildings hit the ground at exactly 90 degrees. They're straight up and down. So a couple things that the questions don't usually say, but they're assumed in these introductory trig problems. So ladder leans against a wall with a 65-degree angle of elevation. So we got to take a look at that elevation, what that means. elevation means above horizontal. Above horizontal. So if you draw a perfectly horizontal line, then the angle of elevation from that line is going from the horizontal and it's going upwards. So right there, so that angle would be 65 degrees there. Distance between the foot of the ladder and the wall is 1.8 meters less than the length of the ladder. How far up the wall does the ladder reach? So we can draw our perfectly straight building hitting our perfectly flat ground at 90 degrees. Right about there. Pretend that is perfectly straight, perfectly flat at 90 degrees. And then we've got the old ladder leaning against this. Let's go a green ladder. Leaning against this, something like that. And they're saying that we have a 65-degree angle of elevation. So we have to go to our horizontal, to our ground down here. This is our ground. This is our wonderful building. You can see all the wonderful windows that people are quarantined inside. And we have a 65-degree angle down there. And the ladder, let's see, distance between the foot of the ladder and the wall is 1.8 meters less than the length of the ladder. So if we choose to call the length of our ladder x here, then this distance between the building and the ladder down here is going to be 1.8 meters less than that, or x minus 1.8. How far up the wall does the ladder reach? So first thing we're going to do is try to solve for x. Once we have x, then we can solve for this unknown, how far up it reaches. First, I'm going to try to solve for x here. So looking at our diagram, I can see that this side must be, x must be my height. If our angle is 65 degrees down here, then this side, our final side, is opposite, and this is height, adjacent down in the bottom left-hand corner. If we have those measurements, first I'm going to solve for something that uses adjacent and hypotenuse. So I'm going to think what uses adjacent and hypotenuse. So CATOA, so I'm going to say that cosine theta is equal to my adjacent divided by my height. I can fill in some values I know and ones I don't know. You can see this looks a little different from our previous problems because I've got cosine theta, theta is 65 degrees, is equal to my adjacent, which is x minus 1.8, and over my hypotenuse, which is just x. So it looks a little different than what we're used to, but you're going to see it only takes one extra line of arithmetic to solve for this one. So I don't like unknowns being on the denominator, so I'm going to multiply both sides by x. So I'm going to get x times cos 65 is equal to x minus 1.8. Then I'm going to bring my unknowns, my variables, to one side, and I'm going to leave my numbers on the other side. So actually I'm going to write this out as 1.8. So I'm going to bring 1.8 over to this side, leave x where it is, and then bring this over to the other. It changes signs as well. So x times cos 65. So I'm going to let the calculator hold these decimals. X times cos 65 is a number. It's like 0.4 something 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 x. So it's like saying 1x subtract 0.4 x's. I'm going to be left with something around 0.6x. I'm going to let the calculator hold the decimals there for me. So what I'm going to do is I'm going to say 1.8 is equal to, I'm going to greatest common factor in x out of both of these, because x is in both of those. I'm going to have 1 minus cos 65. See how it's greatest common factor in x out of there? And I'm doing this just to be a little more accurate than typing cos 65 into my calculator right away. I'd rather type that in the final stages, in my very last line of work, and let the calculator hold all the decimals. So then if I want to solve for x here, I'm going to divide both sides by 1 minus cos 65. Brackets. So now I can type 1.8 divided by bracket 1 minus cos 65. All the decimals will be held in my calculator, and I'm not going to have to round mid-question. So 1.8 divided by 1 minus cos 65. Delete my previous mess here. I've got 1.8 divided by bracket 1 minus cos 65 and bracket. And I get the answer of 3.1175. I'm going to keep a couple decimal places here just because I'm in the middle of a question. I'm going to have to use this later on. So I'm going to keep 3.1175. I'll keep 4 decimal places just to be a little more accurate. And you'll see why, because I'm going to continue to use this value in my next step of the question. So if I wanted to redraw my diagram with a little updated values here, I'm going to have a triangle, something like this. I'm going to simplify it. And we're going to say that x is 3.1175. This is 65 degrees. And then this is 3.1175 minus 1.8, my bottom down here. So 3.1175. Wonder if I can. Yeah, I can. 3.1175 minus 1.8 is equal to 1.3175. 1.3175. 1.3175, remembering my decimal places there. And then they're saying, what is the height of this ladder that reaches up the wall? So they're really looking for this measurement over here. So second part of this question, we're going to use what we found in the previous x to solve for the height, what the question was actually asking. So this is my opposite, and this is my adjacent, and this is my x over here is my height. So I could use multiple different ways to solving this. You could use any one of your 3 trig ratios, or you could use Pythagorean theorem to solve for your unknown side there. I'm going to use, use a trig ratio that leaves opposite on the numerator, just so it's a little easier to solve. So I'm going to use my first one, sine. So sine theta is equal to op over height. Fill in our missing values there. Sine of 65 is equal to op, which we don't know, and that's our question mark, divided by 3.1175. So I didn't really even need to solve for that base, did I? So 3.1175 times sine 65 is going to equal that opposite value. Of course, I could have used cosine, I could have used tan here, I could have used Pythagorean theorem. I just randomly chose to use sine. So 3.1175 times sine 65. 3.1175 times sine of 65 is equal to 2.825, so 2.83. My op is equal to 2.83. Then I'm going to take a look at my question to see what they wanted here. How far up the wall does the ladder reach? It doesn't say where to round this, so I'm going to keep it as 2 decimal places for now. I'll accept that. Your science teacher may argue with me with significant figures there, but for now, I'm going to say 2 places is just fine. So it's going to reach 2.83 meters up the side of that wall. Okay, next one here, somewhat similar of a question. If you want to pause this video and try out the next one by yourself, try drawing that diagram at least. If the math is a little tricky there, you can fast forward and take a look at the math, but at least pause it and try drawing that diagram. Once again, the hardest part, drawing those diagrams. So angle of sunlight is the angle of elevation, so from the horizontal upwards, from the tip of the shadow to the top of the object casting it. If the angle of sunlight is 40 degrees, creates a shadow which is 6 meters longer than the building casting it. How tall is the building? So getting pretty good at drawing my buildings here. Here's my wonderful building. And of course, in this wonderful mathematical world we live in, it is perfectly, didn't quite attach to the ground there, it is perfectly 90 degrees to the ground, and the ground is perfectly horizontal. So I've got a wonderful sunshine up here, casting lots of rays of sunshine. That's hard to see for me. I'm going to switch over to green. It's a green sunshine. But one of these rays kind of comes over the top of this building and hits the ground. That was a bad drawing. Hits the ground something like this. Bad drawing as well. I want it a little longer. Of course, these are all just relative. And they're saying that this angle down here is 40 degrees because that's the angle of elevation, so it goes from the horizontal upwards. And they also say that the shadow, which is 6 meters longer, so the shadow is 6 meters longer than the building that is casting it. So if we label some things here, if I label my building as X, then this shadow casting it is 6 meters longer, is X plus 6. So very similar to what we did before, maybe even slightly easier here. First thing I'm going to do, I'm going to label where my sides are. So across from the angle I'm looking at, across from theta, is 40 degrees. Across from theta is my opposite. So my opposite needs to be X. And that would leave that as my adjacent. My adjacent is ADJ X plus 6. So I've got 2 of my 3 puzzle pieces, and I can simply solve this using my one puzzle piece, my one trig ratio that uses those puzzle pieces. Opposite and adjacent, that looks like a TOA to me, so I'm going to use tan. So tan of 40 degrees is equal to opposite divided by adjacent, X plus 6. So we take a look at the math here. I don't like my unknowns in the denominator, so I'm going to have to multiply both sides by X plus 6. So I'm going to put this in brackets just to clarify here. So if I multiply both sides by X plus 6, that brings it up to the other side. X plus 6 times tan of 40 degrees is equal to X. I'm not going to distribute. Oh, yes, I am going to distribute because one of those doesn't have a variable. So I'm going to distribute this tan 40. It's being multiplied by both things in that binomial. So I'm going to have to distribute to both. So X times tan 40 plus 6 times tan 40. Those are just numbers. I'm just keeping it as tan 40 because I don't want to have a big, long, ugly decimal and round that mid-question. So now I'm going to bring my numbers on one side. So 6 times tan 40 is just a number. I don't know what it is. It's an ugly decimal, but we could solve for that if we really wanted to. Is equal to X, and I'm going to bring X times tan 40 over to this side. So I've got my variables on one side, my numbers on the other side. Same trick as before. I'm going to greatest common factor at an X out of both of these. So I'm going to have 1 minus tan 40. Greatest common factor. Still all equal to 6 times tan 40. Haven't changed that side. Now I don't like, or I want to isolate for X, so I'm going to divide both sides by 1 minus tan 40. This is where students get a little confused because they see that tan 40 and they get real scared. If you think of tan 40 as just a decimal, it's an ugly decimal, so I don't want to write it out. I'm going to leave it as tan 40 and write it all in my calculator at the very end. It just helps keep a little bit of accuracy. I mean, the accuracy is down to like 1/100th or 1/1000th, so it's relatively minute, but it is a good habit to get into, especially if you're going forward in physics and chemistry. So this is what we have to type into our calculator. You can put those in brackets if you want. 6 times tan 40 divided by 1 minus tan 40. So I'm going to go ahead and type that into your calculator. 6 times tan of 40 degrees divided by, nope, see my calculator was trying to divide 40 there, so clearly I need some extra brackets around this, so I'm going to end that and go divided by. That is okay. It can do that in separate steps. Just to make it clear, I'm going to put an extra set of brackets around this whole numerator just so you guys can see exactly what I'm dividing by. And this whole denominator should be in brackets 1 minus tan of 40 degrees. I can do end bracket there. I'll put everything in brackets. So I've got my numerator divided by my denominator, and I get the answer of 31.29. I'm willing to guess if 31.29 equals x. I'm willing to guess if you didn't keep that accurate, if you did just type in tan 40 and you capped 3 or 4 decimal places and you tried to memorize them, rounded to 2 decimal places, you'd probably get the exact same answer of 31.29 meters. I do believe that is. But it just helps. It's a good habit to get in, is to be very accurate, to type in everything at the very one step and let your calculator carry all those decimals. It's much better at remembering decimals than I am. Questions on that, please ask your teacher. So that is the last problem of the day. Next lesson, we're going to go into word problems again. Slightly harder, slightly more challenging, but once again, the same concepts apply. We're just breaking it down into right angle triangles and solving for one of our 2 missing puzzle pieces.